Welcome back to For All Kerbalkind. Both nations are progressing steadily forward, but it seems like the Soviets are starting to pull ahead. So now the Foundation has to match their capabilities. So let's get started, shall we? January 3rd, 1958. The Kel X3 has received an extensive upgrade to its cockpit, and it is now finally flight ready once again. Eileen straps herself in and gets ready for her daring mission. One way or another, she intends to break the Kármán line as the Soviets had the year before. The given flight profile is practically guesswork, but as Eileen is by career a test pilot, this is by no means a new experience for her. Carried up to 13,750 meters at 272 meters per second, Eileen lights the X3's engine and soars upwards towards her goal of reaching space. As she ascends, Eileen pulls hard on the stick, fighting aero forces to keep the X3's nose as high as possible. Approaching 70 kilometers altitude, the X3's angle of attack begins to cause the aircraft to slowly tumble backwards, and Eileen cuts the engine. This low tumble is, luckily, easily brought under control, and Eileen closely watches the altimeter, hoping to break 100 kilometers. The moment comes as the X3 breaks the Kármán line. Eileen keeps the aircraft under control, reaching an altitude of 106 kilometers before beginning to fall once again. Eileen reports down the breathing system is working nominally, control is as expected, and the view is incredible. The dive back to lower altitude is relatively smooth as she pulls a sustained 8 Gs like a champ. It is quickly realized the initial distance the X3 was thought to have covered on a flight like this was greatly over-exaggerated, and Eileen isn't going to make it back to Brownsville. Worse yet, the aircraft is currently gliding over the Sierra Madre mountain range, and places to safely land the aircraft are few and far between. As Eileen prepares to eject from the aircraft at a safe altitude, a suitable valley comes into view, and she brings the aircraft down for a landing. Coming to a stop just west of Saltillo, Mexico, the Foundation must now recover their pilot and aircraft from a bordering country, which is performed with relative ease, thankfully. January 11th, 1958. In the afternoon, a spacecraft called Pilgrim awaits its mission atop a Pathfinder missile. Stored inside of Pilgrim is the Foundation's next space explorer, a small cat. Today's mission intends to expand upon previous Keystone 2 suborbital missions by placing the animal into orbit of the Earth and then bring them back alive to the Gulf of Mexico or someplace nearby. Carried by a larger rocket than before and with newly developed ablative shielding material, the mission is go. Into the flight via visual tracking of the rocket, it is discovered its ventral payload fairing is beginning to burn away. As a counter to this event, Pathfinder is quickly instructed to rotate 180 degrees, giving the fairing in question time to cool down. Moments after doing so, the opposite fairing disintegrates in a fiery explosion. The worst is feared, but fear is quickly quelled by determination as Pathfinder continues to push ahead despite the structural failure. Cutting its engine, Pathfinder lets go of its second stage. Status checks of the payload and second stage provide the Foundation with confidence today's mission has not been compromised, and an abort is not initiated. Instead, Pilgrim will continue to orbit as planned. At T plus 7 minutes and 18 seconds, Pilgrim is in orbit of the Earth. For the next 24 hours, the capsule will contain and sustain a comfortable environment for the small cat in 0G, though they will have very limited mobility in order to maintain survivability when the spacecraft will return to Earth. Meanwhile, all that occurs from biological processes to physical well-being is monitored and transmitted back to ground teams eagerly awaiting the return of Pilgrim for much more in-depth study. T plus 24 hours and 30 minutes, a small facility on the island of Amalek in the Pacific Ocean instructs Pilgrim to fire its retro rockets, deorbiting the spacecraft. Passing over the Hawaiian Islands, another small facility instructs Pilgrim to orient itself for re-entry. From here on out, there will be no signal reaching the spacecraft until it has re-entered the atmosphere. The Foundation crosses their fingers as communication goes dark. Later, communication with the spacecraft is restored, and cheers erupt at ground control. Telemetry reports the parachute has deployed, and Pilgrim is going to touch down in Cuba. Collaborations between the US and Cuban governments lead to the swift extraction of Pilgrim and its spacefaring traveler on board, who is returned home safe and sound, and is given many treats for their adventure. This marks the completion of another successful mission. We got the total of 40 science, 39.8 from the biological sample too, and we also got 10 science just from recovering something from orbit, which is the first time the Foundation is able to do that. Unfortunately, the Soviets did beat us to this last year. However, it's only the beginning of January and we were able to catch up just like that. That amount of science is going to be great. It nets us a total science of 69. Nice. Consequently, that's also the amount of science we got at the end of the first lunar impact. This number keeps popping up. Interesting. But next up, we have another tech node unlocking, 59 to 60 solid rocket engines. So our next flight will attempt to complete 2 contracts here. First is another orbital return, this time from 200 kilometers altitude. And secondly, a WeatherSat contract, because this is a weather satellite. So in order to unlock capsules, there are several requirements I need to meet. First of all, we need early flight control, we need human-rated enter, descent, and landing, we need crew survivability, and we need early human spaceflight materials. I don't quite have enough science to unlock all of these quite yet. And also basic capsules is 31 science, so it also requires an upgrade to our R&D building, which is 500,000 funds, and we now have that amount of funds. And because it's going to take a very, very long time to actually upgrade the facility, I would like to be able to have that upgraded around the same time I need to start researching basic capsules. However, I do need some money left over to tool any new launch vehicle that I decide to build, because our 150-ton launch pad is just about done, and our current vehicle won't make use of that. We can build something bigger. But this is the node that we are gunning towards, so we will ignore everything else for right now. The first thing we're going to get is early flight control with 19 science, because not only does that give us a requirement to get basic capsules, it also gives us the adjacent equipment rack, some rather nice engines for very small payloads, velocity adjustment, it's a nice little engine to have, a new RCS fuel, but also Beardy and I have decided that this tech node will unlock MechJeb's Smart ASS for attitude control, which is much better than stock. No more weird wiggles and RCS fuel being wasted. I love Smart ASS, and we're gonna take that first, and then we have 50.5 science remaining. So what we're going to also select is crew survivability, and then early human spaceflight materials science. This is the X3 that made it past the Kármán line, and we have recovered it. It's been refueled, but there's some modifications I'd like to make. First of all, I would like to change the utilization for these tanks just to fill as much fuel in there as possible. That'll get us a little bit more oomph. And the next modification is, well, a bit more of a major one. We are grabbing air brakes, and we're putting one on the top and one on the bottom. And the reason for this is our flight profile of making it above the Kármán line and all those sorts of things is to fly straight freaking up. And unfortunately, that means we have to dive straight down. And to be honest, diving straight down is going to kill the pilots if we go any higher than what we have been going. And I'd like to see if we can push this a little bit higher. But in order to pull out of the dive, you gotta wait till you're in the lower atmosphere. And if we go much higher than the Kármán line, we're just gonna nosedive into the ground. And then there's two options for us. We could try to pull up and disintegrate the wings and slam into the ground, or we could do nothing and slam into the ground. But with these air brakes installed, we're actually able to slow down really quickly and pull out of the dive without like pulling 10 Gs and ripping off the wings or slamming into the surface. So that is pretty much the only things we're gonna do. It's only gonna take 9 days to do this. So let's go ahead and save the edits. February 9th, 1958. Peter's turn to fly the upgraded X3 aircraft has finally come. Today's flight will follow a similar path to that of the very first X3 flights, gaining speed at altitude before pitching straight up in an attempt to discover just how high the aircraft can get. Now that the Kármán line has been breached, the Foundation is looking for another publicity stunt to one-up the Soviets and bring back a little morale that was lost. Peter will attempt not only to break the Kármán line, but to fly 40 kilometers higher than that mark. New air brakes installed should be able to slow the aircraft during descent in a controlled dive maneuver. Peter ascends with confidence, wrestling with the controls in a vertical climb. More than simply to prove it can be done, this particular flight profile mimics that of a rocket ascending out of the atmosphere and gives our pilots a personal experience with what it could eventually be like to ride on top. The knowledge gained in the air will translate to testing facilities on the ground, providing a base for future Kerbonaut training programs. Unfortunately, Peter only manages to reach 109 kilometers. This will be sufficient for in-flight tests for the new air brake system, but does not meet the particular goals for today's flight. Later discovered after pulling out of the subsequent dive, landing flaps had been jammed open for the entirety of the flight, and so the X3 had performed at less than its full potential. Despite this, it is considered a successful test mission as Peter comes in for a landing. future flight is planned as soon as the aircraft can be refurbished, this time to reach a higher altitude as intended. When you recover vessels from KCT, it saves the state you have parts in, so if engines were on, they will start running. If flaps were down, they will load back into the vessel down. And the way the wings are, I couldn't really see that they were down, and I had no idea until the end of the flight that we had flaps down, and that really hurt us. We still got above the Kármán line, luckily, but we didn't go as high as I had planned to. But we did end up testing the air brakes, and this seems like a very viable option. So Peter Kerman won't be retiring until April of 1960 now, and we're gonna get the aircraft ready for another go. Also, unfortunately, but not a huge loss, I had forgotten to actually accept this contract for X-Planes High, so we're gonna go ahead and do that because when we complete it, we get a total of 100K funds from that, and that's pretty damn good. February 20th, 1958. The Pathfinder 2 space probe has been trickling cosmic radiation and micrometeorite data back to Earth for half a year now, and the final part of its mission is quickly approaching. Tracking systems on the ground have been helping to work out how to accurately predict Pathfinder's trajectory, and it is determined capturing into lunar orbit will not be possible after all. With a lot of guesswork involved, a plan to fire its retro rocket is decided upon regardless, with the intent of flying closer to the lunar surface for scientific purposes, specifically to discover if any fluctuations in micrometeorite strikes occur. The booster successfully fires, and Pathfinder 2 is predicted to fly past the moon 2,800 kilometers from its surface. Then, after sending back home as much data as possible, albeit a very small amount, the probe will drift into interplanetary space, out of range for transmissions, alone in the vast emptiness with no one to talk to. Even though Pathfinder 2 was not able to capture around the moon, we were able to get close enough to the moon with that retro burn to complete a flyby contract, which got us quite a lot of funds anyways. And with that amount of funds, we are going to upgrade the R&D building. That's $500,000 gone, and the remaining funds is left over to develop new launch vehicles, which we are going to be doing because our 150-ton pad is only 47 days away. Alright, due to science collection, we have 3 more points available, and I'm actually going to throw all 3 of them into research and development. March 9th, 1958. Peter again straps into the X-3, aiming to push past the Kármán line and into space. Peter reaches a record-breaking 118 kilometers altitude, though not nearly as high as the Foundation was hoping. At this time, Peter reports that his HTP fuel has been depleted by the main engines. Although the main propulsion system is no longer needed for the rest of the flight, HTP is the fuel used by the reaction control thrusters which orient the craft to dive back into the atmosphere. Without them, the X-3 is falling tail first, something which could potentially destroy the aircraft and endanger Peter's life. Though the situation is tense, both the pilot and ground teams remain calm and reinstate procedures for ejecting from the aircraft should structural integrity fail. For now, Peter will ride this out until lower in the atmosphere. The X-3 is uncontrollable in the upper atmosphere as expected, and Peter controls his breathing as a dead spin begins to emerge. Lack of aerodynamic control means he just has to ride this out, ready to bail should the need arise. The ground spins below as Peter tumbles, and at around 25 kilometers altitude, regains control of his aircraft. The air brakes soon after are fully deployed, and Peter pulls out of the dive with no further difficulty. Too far from the KSC to land back at the runway, Peter chooses a flat patch of grassland to touch down just north of Brownsville. Though the mission is successful, both pilots agree the aircraft has reached its overall potential, and the X-3 program is chosen to be closed down, awaiting scientific progress and the development of a more advanced aircraft. And that concludes the final X-3 flight. Successful, but a little bit scary. Peter's retirement date has been pushed back 126 days to August of 1960, and hopefully we'll have capsules by then, because I'd like our first 2 Kerbals to go up into space in a capsule. I just think that would be so cool. So we have that possibility. I'm going down here to accept the first orbital flight contract, and by accepting this contract, all the X-plane contracts will go away, but I want that advance of almost $1 million funds pretty badly, and we'll be able to do this within, how many years is that? 5, 6 years? And we should have capsules within 2, I'm hoping. So we'll accept that. We have 1 million funds to work with. Okay, I've given our site in Wallop 6 more points, and now we are going to throw 12 into the VAB and 20 into our R&D. So this is the build of Discoverer 1. It is going to be a weather satellite and a Earth photography satellite using the early film camera. Now this experiment isn't very fruitful and only lasts something like 10 minutes, but it is biome specific, so there is plenty of science to be had with it. This is the first time we're actually putting it into orbit. I believe we launched it suborbitally for quite a while, but we only got science from, I think, a little bit from the shores. But mostly just from the ocean. So we're putting this in orbit and going to try to get it over some different biomes. Now this will also complete a contract to bring something back from orbit above 200 kilometers, and it will complete a WeatherSat contract as well with 40 WeatherSat payload on board. Now the first time we rolled this out, the contract requirements window decided to think we didn't have any WeatherSat payload on board. So we had to roll it back, check it in the editor, at which point I discovered there was still WeatherSat payload. Then we rolled it out, wasting a week of time, but it's not really that big of a deal. It was very interesting though, because we had WeatherSat payload the whole time, but it wouldn't have completed the contract, and I couldn't find it in the actual craft on the launch pad for some reason, because I didn't remember where I put it at that time, because we actually built this last episode halfway through the year. But yeah, this is ready. We're gonna slap it on a Pathfinder and call it good to go. April 2nd, 1958. After an aborted launch 1 week prior for payload inspection, Discoverer 1 sits atop a Pathfinder 2 launch vehicle, ready for its mission. The Astro Foundation has decided to postpone further lunar exploration missions until more ambitious scientific endeavors can be conceptually performed. Essentially, until rocket stages are able to propel higher tonnage towards the moon. Meanwhile, scientific research of the Earth from space has never been more appealing. The Discoverer program aims to photograph the Earth from space, and this first satellite intends to prove that recovery of physical film from orbit is in fact possible. In the morning, the new satellite lifts off from Brownsville for its short mission. Three and a half minutes into the flight, Pathfinder's second stage engine fails to ignite. The satellite will not reach orbit and will not be able to test its primary functions. However, the ejection system for its return capsule is able to fire and return to the Earth safely. Inspection of the returned capsule proves the concept is viable and indicates camera film should be intact after re-entry. Despite today's failure, the Discoverer program is go. Our 150-ton pad has officially completed construction. It's much larger of a complex, which means our bigger rockets are good to go. May 20th, 1958. Intelligence suggests a Soviet lunar mission has recently been launched, though the intent of this mission is unclear. Days later, on May 22nd, the Soviets have openly declared they have successfully navigated a space probe into orbit of the moon. something Pathfinder 2 had failed to accomplish. Up to this point, the Foundation's lunar exploration has not been matched, but now it appears they have been surpassed. Furthermore, it is painfully evident the United States is in the dark regarding Soviet launches, something which some perceive as a major threat. Clearly, something must be done about this. This is the build of Scout, a brand new launch vehicle that's going to be launching from a 20-ton pad in Wallops, Virginia. Now, this is, of course, based off of the Scout with a C rocket that the US has used for quite a long time. I don't think it's in use anymore, but it was definitely in use for quite a long time. Now, this is all solids, so it is 4 solid stages that will put a very small payload into orbit. The current iteration I'm building here isn't quite capable of putting as much into orbit as the first Scout actually did, and I think that I can blame this on the fact that our avionics are extremely heavy at the moment. So as tech progresses, we'll be able to put more into orbit, but right now we are barely capable of putting a small avionics core with something able to keep it alive with some solar panels. We're barely able to put that into orbit. However, we are going to be launching a few of these up, and they should stay alive for quite a long time and provide a sort of a not specific communications network. So that is our plan for these. We'll be launching a few of these every year from Wallops, and our first test is now. August 19th, 1958. The Wallops, Virginia launch facility resumes flight activity once again. A brand new Scout program has been born, and today is its maiden voyage. The vehicle weighs roughly 19 tons, consisting of 4 solid rocket stages. Sitting atop the launch vehicle is a small communications satellite. Its mission will be to reach low Earth orbit, then await several more Scout launches in the future to become part of a network that can redirect UHF frequencies across the globe. Although these satellites will be utilized strictly for official Foundation missions, minimizing so-called blackout in low Earth orbit. If the technology works, it will prove ready for commercial and public use. Being able to transmit information to the other side of the planet in a blink of an eye leads to endless possibilities in the future. Scout 1 fires its first solid rocket stage and lifts off from Wallops. "50 seconds into the flight, the first stage explodes, hurling the rest of the rocket into an unrecoverable spin. 3 minutes and 21 seconds after liftoff, the range safety officer terminates the mission, and the first Scout launch results in failure." This is the Foundation's brand new launch vehicle that was patiently waiting for the 150-ton launch pad to unlock. And this is, of course, based off of the Atlas, but is called the Catlas because, well, this is Kerbalized after all. And I actually have streamed the footage for building this, and it was about a 7-hour stream. And unfortunately, I just personally don't have the time to go through 7 hours of footage and edit it down into a cohesive clip of this build. But the most complicated thing is, of course, the skirt, so I figured I would show this just in a more simplified fashion. But if you would like to see the entire build of this rocket, well, except for a few little aesthetic goodies at the end, the 7-hour stream is being uploaded to YouTube, and there should be a link in the description or somewhere, or you can just go to my channel and find it if you want to watch that entire thing, because Twitch only keeps them for about 2 weeks before it deletes the videos. So I thought I'd put it on YouTube in case anyone would like to see. Now, to get to the good part of how this skirt actually works, it is primarily procedural fairings, but there is something interesting that we have to do in order to keep this from glitching out when it decouples. So the secret to this is right here, the cubic octagonal strut Mark 1. Now, this is the piece that has a decoupler to it, which allows us to move the entire skirt independently. So I'll give you the rundown of how to build a skirt like this for yourself. It is basically using any sort of fairing base that you would like to use, because what we're doing is simply using that base to form the shape of the fairing that you'd like, and then taking that shaped fairing off and attaching it via nodes to the octagonal struts, which are just sort of clipped into other pieces. It's basically just putting nodes where there isn't nodes, so we can attach these fairings like we want. There's an issue with these bases, and this is why we actually get rid of them. Not only do they add like dry mass, but apart from that, is this skirt will not decouple cleanly with these bases like clipped into the engine there. And I sort of discovered it was this KSP. It's not a bug, it's just how it determines like where the node is. If it determines there is structural pieces inside of where the decouple node is specifically with these bases, it will just throw the skirt off of the end of the rocket really fast, and that's not really what we're looking for after all. So essentially what you can do with procedural fairing bases is turn off auto shaping and then use cycle start, I think is what it's called. Adjust that to be very small and change the initial diameter of the ring itself of the base part. And then you can make this sort of flat cap at the end. And now making a few of these fairings, shaping them how you would like them to look, and then placing them via these magic nodes the cubic stress creates will give you that skirt. And all of it is attached on one side. It's basically making only half of it at once. And the reason for that is because you can't really work with symmetry if you do it as a whole. So if you can set the fairing nodes to 1, which will make a perfect circle for you to use, but the symmetry I found can be a bit off. But honestly, you probably could do it with just 1, but what I did for this build is use 2 halves and then simply build 1 half of the skirt entirely, and then it's all connected to one base fairing, so you can copy that fairing, which copies the entire skirt, and you attach that to a node on the same skirt, and then simply adjust it over to the other side. It's not entirely perfect, but I got it as close as I could get to centered, so that you can't even tell that it might be like a millimeter off centered. But luckily, these gimbals for the engines will take care of that perfectly fine. And that's sort of how I built the skirt. And there's probably a better way of doing this. Like I said, you could probably do it with a single node to make it easier for yourself. But this is just how I ended up doing it. And I spent the entire 7-hour stream just like figuring out, okay, why is Kerbal Space Program just yeeting the skirt off? And there's plenty of simulations where we tried one thing, yeeted it off. It was just a long process that hopefully that can help you out with this summarized version if you are looking to make a skirt for yourself. But without further ado, let's see the Catlas in flight, shall we? August 23rd, 1958. A brand new launch vehicle sits ready for launch in Brownsville, Texas. The Catlas A missile is given its first orbital mission today. Its payload is a large satellite capable of taking images of the Earth from orbit and returning its physical film back to the ground safely a little less than half a year later. Named Discoverer 2, this satellite intends to complete scientific research as previously described during Discover 1's failed mission. However, for the first time since the Astral Foundation's inception, this mission is veiled in secrecy. There is no doubt important scientific research will be performed throughout its mission, but only a select few individuals truly know the reason for all the secrecy. The NRO and US Air Force intend to use Discoverer 2 to photograph Soviet launch sites and manufacturing facilities. This insight will prove to be invaluable to national security and defense, and is highly classified under the term Operation Keyhole. Though it must be clarified, this is top secret information not known to the public. If the Soviets knew, well, nobody aims to find out what happens then. The Catalyst A lifts off from the pad, and Discoverer 2 is on its way into orbit. Unlike any other current missiles to date, the Catalyst sports a unique tank structure. A lightweight, highly pressurized balloon tank encompassed in a stainless steel exterior holds the fuel for 2 booster, 1 sustainer, and 2 vernier engines, all lit on the ground, lifting the Catalyst into the atmosphere. At T plus 2 minutes and 20 seconds, however, the Catalyst jettisons its booster engines, leaving only the sustainer and small verniers to reach orbit. A few minutes later, the main stage burns through the entirety of its propellant, just shy of orbit, and Discoverer 2 is detached. During periods of connection with ground teams over the next half hour, small onboard thrusters will propel Discoverer to a stable orbit of 344 kilometers by 210 kilometers. The satellite's orbit is inclined by nearly 64 degrees to the equator, which allows its cameras to view as much of the Earth's surface as possible with the current launch vehicle's capabilities. Its solar panels should keep the satellite powered for an allotted 5 months, at which point the cameras will have run out of film, which will be fed into a return capsule to be deorbited. Ground teams begin work monitoring the satellite's systems and orientation for the next half year or so, while on the more secretive side of things, certain images being taken are highly anticipated by those who are aware of them. October 1st, 1958. For almost 8 years, the Astral Foundation has conducted aerospace research for the US Air Force, and this relationship will continue on into the future. However, the ambitious scope of space exploration has led to the formation of a brand new federal agency known as the National Aeronautics and Space Administration, or NASA. Established and funded to facilitate ventures into space, NASA reaches out to solidify the Astral Foundation's role as their primary contractor for future missions. Long-term goals are discussed, beginning with a plan to develop a structure for safe and sustainable crewed spaceflight in 1 year's time. October 15th, 1958. The Foundation's third lunar exploration probe, Pathfinder 3, waits atop a C-variant launch vehicle by the same name. The launch vehicle has recently seen upgrades to its primary and secondary engine, the goal for this being greatly improving reliability, something which has been lacking during previous missions, causing them to fail. This does come with a slight performance loss, which is countered and even negated by the addition of 2 Castor 1 boosters helping to lift the vehicle from the pad. Pathfinder 3 has been especially designed for lunar impact, with onboard temperature and pressure readings to be transmitted up until reaching the surface. Successfully reaching orbit, the impactor is spin stabilized at the correct orientation for its translunar burn. Its deployable antenna slowly extends during this time as well. 26 minutes after liftoff, Pathfinder 3 is detached and its booster is instructed to fire. Although an initial impulse is detected, it is quickly realized the engine experienced some sort of malfunction and has failed to ignite. Pathfinder 3 is left adrift in low Earth orbit, expected to hold power for 2 weeks before going dark. Our R&D building is just about to be upgraded, and we'll see it actually speeds up our research. Early human spaceflight materials science had been taking 123 days, and now that knocked it down to 99 days. So that's going to speed up our research. That is really, really good to know. December 8th, 1958. Late in the night, Pathfinder 4 intends to complete a previously failed lunar impactor mission. Lifting off from the pad, the mission is go. Just shy of 3 minutes into the flight, the first stage prematurely shuts down. Luckily, trajectory remains nominal, and the second stage is more than capable of reaching orbit despite this. Once in orbit, Pathfinder 4 is spin stabilized at the correct attitude and awaits its translunar injection. Above the coast of Africa, Pathfinder 4 lights its booster and is on its way to the moon. Small reaction control thrusters perform final velocity adjustment, ensuring an impact trajectory in 4 days' time, at which point the probe will send back a wave of scientific data just before impacting the lunar surface. Four days after liftoff, Pathfinder 4 is destroyed, successfully completing its mission. December 20th, 1958. Discoverer 2 has been instructed to return to the Earth earlier than initially intended. The Foundation has been monitoring spacecraft systems and determined its power would not be efficient to operate the orbital camera effectively for much longer. Retro rockets fire at a precise time to bring the capsule back to the Alaskan coast, but this causes the satellite to enter an unplanned spin. Onboard reaction control thrusters are able to correct the movement, and luckily, telemetry indicates it is on course for a re-entry trajectory. During its 118-day mission so far, it has captured merely 8.5% of the total possible images able to be recovered. Solar panel degradation is partially to blame, but had avionics taken less power, Discoverer would have been at full potential. Work towards developing such technology is definitely of interest. Computers are quite power hungry and will have to become smaller and more efficient for these missions to work out. Regardless, the images once recovered will definitely still be valuable for various reasons. Bright streaks of light and fiery explosions soar silently through the starry sky above the Alaskan coast as the satellite disintegrates in the atmosphere a ways ahead of the capsule. The film return capsule safely re-enters Earth's atmosphere and signals to a ground team in Kodiak, Alaska, that parachute has successfully deployed. Unfortunately, the capsule is silently floating down somewhere in the mountains just north of Alaska, along the Yukon-British Columbia border. Retrieval teams are sent the next morning to collect the capsule and film within. Another successful year comes to a close. Despite various failures, definite improvements have been made. We have a brand new launch vehicle, NASA has officially been formed, and crewed orbital flight is just around the corner. Next year should definitely be an exciting one. With the science gained from Pathfinder 4, we were able to unlock human-rated entry, descent, and landing, and this is the only final requirement before we have access to basic capsules. 31 science node, we have 17 science now that we've returned Discoverer 2 from orbit. We would have a lot more if that satellite was actually capable of bringing back the maximum of 40 science, but alas, impact missions are going to get us about 15 at least science, and that's without running our small science experiments, so we're looking at around 18 to 19 science. But just with that 15, that brings us up to 32 science, just barely enough to unlock basic capsules. So next episode, we will be flying a lunar impactor mission, and we will be unlocking capsules. Now, it's going to take some time to actually unlock. I have quite a lot of funds, 764K. So we are definitely going to be speeding up research and build times, but without that, it's going to likely take most of next year to unlock the capsules, and then after that, it's going to take a while to actually build with the capsules. But with the money we have, we're likely able to speed up build times and research, and definitely attempt a suborbital flight of the capsule. And if all things go well, attempt to put a Kerbal into orbit by the end of 1959, the end of the first decade. But we will make that glorious attempt next episode. If you would like to see what the Soviets have been up to this year, 1958, a link to Beardy's video and channel will be in the end screen and description below, where you will also find a link to my Discord and a new Patreon that was just launched this week. Now, I believe that Beardy had some lunar missions and crewed spaceflight up his sleeve in his Ka-4 aircraft and Luna program, and I did my best not to spoil anything for this episode, so definitely go check that out. Anyways, I want to thank you guys so much for watching, and peace out.